Today, let's look at a well-known formula in geometry, which is called the Heron's formula. And this formula relates the area of the triangle to the side lengths of the triangle, which is ABC. So the area of the triangle ABC is equal to the square root of s times by s minus a times by s minus b, s minus c, where s is the semi-perimeter of the triangle, which is a plus b plus c over 2. So for the proof over here, we will first note that the cosine of C, the angle C, is equal to a squared plus b squared minus c squared over 2ab. And this is just by the cosine rule. So now we have that the area, which we'll denote it as A, is equal to 1/2 AB sine C. And this formula is pretty well known because we now have that the BC over here is actually the altitude, which you can see by this diagram over here. If we drop a perpendicular line over here, and then by a simple trigonometric identity, you can see that this length over here is the altitude, which is b times by sine of the angle C. And now we want to find the sine of angle C, so we can actually see that the sine of angle C is actually equal to the square root of 1 minus the cosine square of the angle C. And we can plug the formula of cosine C relating A, B, and C into this expression over here. So we get that this is the square root of 1 minus the square of this whole chunk of thing over here. And then let us just expand off everything. So in the end, you get that this simplifies into the square root of 4a squared b squared minus a squared plus b squared minus c squared, the whole thing squared, over 2ab in the denominator. And then we will now proceed for the area, which is equal to, we have that this is 1 over 4 times by, let's see, we have that this is the square root of 4a squared b squared minus a squared plus b squared minus c squared, the whole thing squared. And then, but first, we will now observe that we can factor this as a difference of 2 squared, which then we'll get this 2ab minus a squared plus b squared minus c squared. And then we'll times by 2ab plus a squared plus b squared minus c squared. So now we'll have that this simplifies into 1 over 4. We can group the 2ab and a squared plus b squared together, so we'll get that this is c squared minus a minus b, the whole thing squared, times by a plus b, the whole thing squared, minus c squared. And then by using the difference of 2 square formula again, and then now we can move the 1 over 4 inside this square root, so we'll get the denominator over here is over 16, and then the difference of 2 square gives us c minus a minus b times by c plus a minus b, and a plus b minus c times by a plus b plus c. And now we can separate the 16 into 4 2's, which will get that this is in fact equal to the square root of b plus c minus a over 2 times by a plus c minus b over 2 times by a plus b minus c over 2 times by a plus b plus c over 2. And then you can note that this whole thing is really just equal to the square root of s times by s minus a, s minus b, and s minus c, which you can note that this term over here is equal to s, this term over here is equal to s minus c, and this term over here is equal to s minus b, and the remaining one is equal to s minus a. And so therefore, we have proven the Heron's formula. So we are done for this video. If you want to solve more geometry problems, then be sure to watch this video over here.